Foundations of Amateur Radio. When the sun burps, something that it does regularly, the mainstream media starts talking about aurorae and optionally the end of the civilised world. Not always as clinically as that. What's not talked about, let alone explained, is the nature of the solar burp. You've likely heard the terms Coronal Mass Ejection, or CME, solar flare and perhaps solar wind, solar and geomagnetic storm, and solar flux. But what do these terms actually mean, and how do they relate? Let's start with some basic numbers. Our Sun is 150 million kilometres away from Earth. As seen from Earth, the Sun rotates on its axis every 27 days, called a synodic rotation period, because while the Sun is rotating, Earth is moving too. If that wasn't enough, the Sun isn't solid. Depending on where you're looking at it, rotation happens at different speeds, faster at the equator, slower at the poles. You might have heard of the solar cycle, an 11-year period during which solar activity steadily increases. Near the maximum activity, its magnetic poles flip from north to south, and activity slowly decreases until the cycle starts again. Until quite recently, we've deduced this by counting the number of dark areas, called sunspots, on the surface of the Sun. All this to say that our Sun is one massively dynamic environment, and with it come a whole lot of processes that science is still discovering. The YouTube channel Astrum has a fascinating video called "We Didn't Predict the Sun Would Do This" that describes much of what we're still learning. We experience the Sun as a source of light, but as a radio amateur you know that light only represents a small set of frequencies in the radio spectrum. It's better to think of the Sun as a radio source, emitting many frequencies at once. The strength of this is measured at 2.8 GHz 3 times a day, at 1700, 2000 and 2300 UTC at the Dominion Radio Astrophysical Observatory in Penticton, British Columbia, Canada. This measurement, the Solar Flux, gives a good indication of the level of solar activity. Adjusted for the varying distance between Earth and the Sun, a solar flux index, or SFI, below 70 means that solar activity is very low. Above 150 is considered very high activity. In addition to radio waves, the Sun also spits out a continuous wave of particles. Different parts of the Sun emit these at different speeds, varying between 300 and 800 kilometers per second. These particles, the solar wind, exist throughout our solar system. Because the Sun rotates and the particles aren't being emitted evenly, we experience the solar wind as having a 27-day cycle. Think of a water-filled beach ball hanging from a rope with a hole in it, spinning, creating spirals of water. Stand in one spot, and every time the ball rotates, you get hit by water. When the Sun burps, often at a sunspot where concentrations of magnetic fields cool the surface, bursts of electromagnetic radiation are generated throughout the radio spectrum. Measured in watts per square metre, this radiation is called a solar flare. Travelling at the speed of light, it takes about 9 minutes to arrive at Earth. Sunspot and solar activity is used to model and predict the potential for solar flares. Strength is classified in 4 stages, Class B being the weakest, through C, M and Class X being the strongest, each 10 times more powerful than the previous. Within each class, numbers 1 through 9 serve to provide additional resolution, X2 being twice as strong as X1. The most powerful flare on record was estimated to be about X45, recorded on 4 November 2003, When at strength x17, the sensors overloaded. Some solar flares coincide with a massive eruption of particles, some of which are ejected violently, called a coronal mass ejection or CME. A slow CME, travelling at 500 kilometres per second, might take 3 days to hit Earth. An extreme CME, travelling at up to 2,500 kilometres per second, might arrive in 16 hours. As the CME particles arrive, they distort Earth's geomagnetic field, and depending on the severity, might cause a geomagnetic storm where fields are pushed closer towards Earth, causing visual effects as aurora. Recovery generally takes up to 2 days, but in extreme cases has been observed to take 4. Disturbances of Earth's magnetic field are highly variable and are expressed in several different ways. The K, KP, A, AP and G indices. The K index, measured at individual observatories, ranges from 0 to 9 over a 3-hour period, represents the maximum horizontal fluctuation in the geomagnetic field. Values of 5 and above indicating a geomagnetic storm. The planetary KP index represents a weighted average of 13 mid-latitude observatories. The National Oceanic and Atmospheric Administration, or NOAA, uses a G scale between 1 and 5, equivalent to a KP index between 5 and 9. The A index is derived over 8 K index readings over a 24-hour UTC period at a particular observatory. Below 20 is calm, between 20 and 50 is unsettled, and above 50 is a stormy day. The AP index is an averaged planetary index based on data from a set of specific KP stations. There's more. In 1760, a publication by Swiss polymath Leonhard Euler indicated the existence of 3 stationary points between any 2 large bodies, known today as L1, L2 and L3. In 1772, Italian-born French mathematician, physicist and astronomer Joseph Louis Lagrange discovered 2 more stationary points, L4 and L5. Known as the Euler-Lagrange or Lagrange points, some of these locations are being used today for solar observations, predictions and early warning systems. Launched on 24 September 2025 and in orbit at L1 between the Sun and Earth at a distance of 1.5 million kilometres from Earth, the Solar 1 satellite acts as an early warning for solar storms. Since particles travel slower than the speed of light, this provides about 15 minutes warning for extreme CMEs, and longer for slower events. It became fully operational on the 10th of June 2026. As part of the same Space Situational Awareness Program as Solar 1 is the European Space Agency's Vigil space mission. Intended to be placed at L5, 150 million kilometres from Earth, it will be able to observe solar activity as the Sun rotates towards Earth, and reports indicate that this will increase early CME warning by 2 to 4 hours. Vigil will also allow for 4 to 5 days space weather forecasts. It's planned for launch in 2031. Mind you, it's going to take 3 years to get to L5. Aimed with all that information, I was actually, for the first time, able to at least understand the solar report in my Mastodon feed. Quote, "The sunspot number has dropped to 88. The Solar Flux index has risen to 149. G1 class geomagnetic storms are predicted for today. A index is 14, K index is 2. Chance of flares today, 55% for M class, 10% for X class." End quote. Armed with that information, I'm going to make myself a cuppa and figure out what my whisper beacon has to say about all this. I'm Onno, Victor Kilo 6, Foxtrot Lima Alpha Bravo.